All right, here's our video for section 4.4, building quadratic models, given verbal description. So the marketing department of Texas Instruments has found that when certain calculators are sold at a price of P dollars per unit, the number X of calculators sold is given by the demand equation of X equals 21,000 minus 150P. Find a model that expresses the revenue R as a function of price. Well, if you want to find revenue, you got to take the number of calculators, which in this case will be our X, and multiply it by the price. So our revenue is X times P. So in this case, X up here was equal to 21,000 minus 150P, and we'll multiply it by the price P, and there is our equation. Don't get this confused. This isn't function notation right here. This is X times P. Or if you want to write it as just XP, that's fine as well. So what I just noticed here is that we have created, if you multiply in the P, you have created a negative 150P squared. So with our knowledge of quadratic graphs, we know that this is a parabola that opens down. And the vertex is going to represent the max for this parabola. So it wouldn't surprise me if sooner or later we come along and we're going to find that we have to find a maximum value of something. Part B says, what is the domain of R? To find the domain of R, take each factor and solve it, set it equal to 0 and solve it for P. So our two factors are this binomial, 21,000 minus 150P, and the P. So I set both of those equal to 0. So I add over the 150P to the right side of 0, divide by 150, P is equal to 140, and of course this P is 0. So our domain is going to be 0 less than or equal to P, less than or equal to 140, or we can put that in interval notation, bracket 0, comma, 140, bracket. Now, why can we be equal to? Well, we can be equal to 0, we can be equal to 140. If we're equal to 0, all right, if we're equal to 0, then we're going to get rid of all 21,000 calculators because they're free. If they're selling for 140, we are not going to get rid of anything. I'll bet you 150 times 140 comes out to be 21,000, and you're not going to be able to sell anything. It's too big. So finding the domain is always setting each factor being multiplied together, the number of calculators and the price. Whatever your factors are, set them equal to 0, solve for that variable. What unit price should be used to maximize the revenue? Well, let's graph it and then maximize it. So we can go to our calculator, and here's my TI-83 shots. I think we'll be good with that. We've done so many maximized problems so far. I typed in the factored form. It doesn't matter which one you type in. So there's my 21,000 minus 150x in parentheses times x. All right. Now, because we found the domain, I'm going to hit the window button, and I'm going to put 0 for x and 140 for the max. 0 for the min, 140 for the max, because that's the only part of the parabola we want to see. What I'm not going to do is I'm not going to change the y's. I really don't need to change it. I know that the max has to be somewhere between 0 and 140. So I'm just going to hit graph, and I get an ugly graph. I'm going to maximize it, so I hit second trace, ask for the maximum, left bound, just use what you were given for the domain. Left bound 0, right bound 140, maximum is 70.00009. Wait a minute, all these decimals, and our maximum revenue is 735,000. There's no decimals. This is a rounding error. Oh, wait a minute. I should have known it was 70 right away. Because remember, between my two x-intercepts here of 0 and 140 has to be that axis of symmetry that cuts the parabola in half. So what's halfway between 0 and 140 is 70. I didn't even have to graph it. Once I knew these two factors that were set equal to 0, those are your x-intercepts, 0 and 140. So halfway between that is 70. That's going to be the location of our vertex. Remember, excuse me, we did that on that one problem that said find the equation of the 3 points, and we had, what was it, 3 comma 10, 7 comma 10, and we knew that the axis of symmetry had to cut the parabola in half. Yeah, we take the average of the two x's and divide it by 2. Oh, 0 plus 140 is 140 divided by 2 is 70. So that's the price right there. I didn't even have to make that graph. I can't believe I forgot that. Well, from now on, we'll use that if we come across that. So if the price is charged, what is the maximum revenue? Well, that's this y coordinate right here, $735,000. If you want to double check, you can take $70, plug it into the p's here and here, or in this equation, but you'll get $735,000. How many units are sold at this price? Wait a minute. Okay, that's this equation right here. It's 21,000 minus 150p. We have to put 70 into that equation right there. So I would go to my home screen, type this in, 21,000 minus 150 times 70. It came out to be 10,500 calculators. All right. And the very last question says, what price should Texas Instrument charge to collect at least $675,000 in revenue? So that means R of P is equal to $675,000. We plug that into our first equation, or the second one, it doesn't matter. I went with the second one this time. And I've created an equation that I need to solve for P. And we can do this algebraically if you like. And I'll show you another technique that will work out really quick and easy as well. So I am going to, first of all, notice that I need to get rid of this leading coefficient on my p squared. If I want to solve this, I want to try to factor it, and hopefully I think that 150 is going to go into both of these numbers. And here's how I know that. Well, they end in zeros. 150 is a multiple of 5 and 3. 21 is a multiple of 3. 675, 6 plus 7 plus 5 is 18. So that's divisible by 3, and it ends in a 5 there. So I know it's divisible by 5 as well. So let's go ahead and divide it out to negative 150. And I get negative 4,500 from my calculator equals, now because I divided by negative 150, that makes this a positive p squared. And 21,000 minus the negative 150 makes that a minus 140p. Let's set it equal to 0. Let's add the 4,500 over to the right, and let's factor this. Now, big numbers, easy factor. Huh? Yep. Whenever your middle term ends in a 0 and your constant ends in 2 zeros, that means my two factors end in 0. So cover up that 0, my number's 14. Cover up these 2 zeros, it's 45. What two numbers multiply to be 45 and add up to be a negative 14? 5 and 9. 5 times 9 is 45. 5 plus 9 is 14. Let's just make them negative. So 5 and 9, now you put the zeros on them, and negative 50 times negative 900 is a positive 4,500, and negative 50 and a negative 90 adds up to be a negative 140. Solve these for P. P equals 50, P equals 90. So as long as you sell somewhere between 50 and 90 calculators, Texas Instrument will have at least $675,000 in revenue. Okay? Now, the second way we could have done that is we could have taken our graph, go to y sub 2, type in 675,000. Now we're probably going to need to adjust our screen. So we know we have to have a y max bigger than 735,000. So I made it 800,000. And for my old 83, you don't have to do this for the 84s anymore. but I wanted to get the x-axis off the bottom, so I made it negative 200,000. So I can see this is the downside of the 83s, that when you hit the numbers on the bottom, they're on your graph. So you always wanted to raise the x-axis off the ground a little bit. So finding the intersection, so second trace, go to the intersection command. First curve is y1, second curve is y2. Enter on the guess, it gives you the intersection at 50 and 675,000. So that's how you can find 50. And you can do the same thing over here at this point. So you got to move your cursor over to here, past the intersection, because we don't want it to go back to this one. So do the intersection again, first curve, second curve, enter on the guess, you get 90. And that's another way you can find those two price values. Okay, next word problem or model. We have a farmer has 2,000 yards of fence to build 2 adjacent rectangular corrals. What are the dimensions of each corral to maximize the total area? Okay, wait, maximize again. We want to see a parabola that opens down. So again, you have to have a negative variable squared somewhere. All right, so let's build a diagram of 2 adjacent rectangles. There they are. So this one side is being shared between 2 corrals so we can get more area here. Next, we'll need the area formula of a rectangle, and we're going to label all the sides of our rectangle. So again, you can use base times height, length times width, whichever you want. I'm going to label the segments, not the whole sides. I like to measure my X, or I should say my horizontal segments, with an X. So don't make the whole bottom 1x. You have 2 different corrals. It said, what are the dimensions of each corral? So you want to label each side of the corral with a variable. The vertical, I'm going to make those y's, just like it's my vertical axis. So we want to build a area formula. A of x is equal to the base. Well, the base are the 2 x's being added together, but my height is y. We don't want y here in our equation. So we're going to have to do some work somewhere to change, find a relationship between your x's and y's other than the area, and be able to solve that equation for y so we can write it in terms of x. Well, you know what? We haven't used 2,000. And 2,000 represents all your building material for the fence. So that means we have to add up all these variables, 1, 2, 3, 4 x's plus 3 y's has to equal 2,000. So that's my other relationship between x and y. Solve it for y. Subtract over the 4x, divide by 3. All right, we have a fraction. No problem. We'll put that in there. So here are my 2 factors. Now, we could go to the calculator and do this, but we've got that concept that these 2 factors are going to be your x-intercepts. We learned that in the previous problem. So I'm going to set this equation equal to 0. Remember, this is your y because we're going to have to come back and use this equation. So I'm setting this equal to 0. So 2x equals 0. And this whole fraction equals 0. Well, 2x equals 0 means x is equal to 0. Here, you can multiply the 3 to the 0, and that's a 0. So I got rid of the 3 in the denominator. Add over the 4x. 4x equals 2,000. Divide by 4. X equals 500. Remember, when you have a fraction with a constant in the denominator, the only way it can become 0 is if the numerator is a 0. So you could just set the numerator equal to 0 as well. All right, so that's my domain for my x. So we're going to graph it to max it. But this time, I'm just going to make a sketchy graph. I don't have to go to my calculator because I know 0 and 500 are my x-intercepts. I know, too, that the parabola opened down. Why? Because 2x multiplied to a negative 4x would be a negative 8x squared. So the leading coefficient in front of my x squared is negative. The parabola has to open down. These are my two x-intercepts, and then halfway in between is my axis of symmetry, and halfway between 0 and 500 is 250. That's the h, or the x, coordinate of my vertex. Okay, so my x's up here are all 250. So there's, if you will, one dimension of my corral. Now we got to find the y. Well, remember, inside the parentheses, this is what y equals. So we're going to put 250 in for that x right there. 2,000 minus, let's see, 4 times 250 is 1,000. That's 1,000 over 3. So there's my dimensions. My corrals are each 250 yards by 333.3, or 333 and 1/3 yards. And that takes care of our video for section 4.4.